Okay, we've been talking about factoring, and I'm going to try to still convince you of the usefulness of factoring. Okay, here we have an equation. Uh, it says y equals x squared plus 6x plus 8. We're supposed to graph this. Okay, now one of the steps that we use in math to graph this type of problem is we want to find the x-intercepts. And so in order to find the x-intercepts, we need to factor this equation. Okay, so we know how to factor this. Okay, so we're going to factor the two binomials. This is plus, so we're going to be adding. We're going to be adding to find 6x. We're going to use this number. Factors of 8, 1 and 8, 2 times 4. So 2 times 4 is 8. And then 2 plus 4 is 6. So we're going to put here x and x is x squared. And then we're going to put plus 2 and plus 4, because 2 times 4 is 8. And then 2x and 4x with FOIL gives us 6x. Now, remember this is still equal to 0. Okay, so now if we solve this, again, remember, we're trying to use the zero factor theorem. We have to make these two factors here 0. So what can we replace x with in order to make this 0? Well, we think about it a little bit. If I plug in a -2 here, that's going to give me a 0 here. So -2 is one of my solutions. So I put in a -2 here, I'm going to get +2. And so 0 times +2 is 0. So this is going to work. Okay, so then my other answer, my other root is we're going to plug in here a -4 to get that 0 here. So if I plug in a -4 for x, this is going to give me a -2. So -2 times 0 is 0. Remember the zero factor theorem? If you have a times b is equal to 0, either a or b are 0, then either a or b can be 0. Alrighty, okay, so we've just solved this. Okay, but we want to write this in using intercept form. Okay, so if x is equal to -2, I'm going to put in -2 and 0 right here. And then my other x-intercept is -4 and 0. Okay, and this part, on the final exam, a lot of students missed this question because they put this as the answer, -2 and 4, and they want it in ordered pair form. When they ask for ordered pair form, you have to put the symbols, you have to put in parentheses, and then the two numbers, and then a comma in between them. Okay, so now we can start to graph this this equation. Okay, this is my x-axis, this is the horizontal, and this is my y-axis, this is the vertical. And I'm going to, remember I put arrows here at the end, should have arrows because that means it's continuous. Okay, so -2, this is 0 here, the origin, -1, -2 is here. So I'm going to put a dot here. This is a point. So that's -2, 0, that's this one. Okay, the next one, -4, 0, this is 3. Well, these should be equidistant apart. That's not a good mark, but this is -1, -2, -3, -4. -4, 0. Okay, so we'll put another point there. Okay, that's these 2 points. Let's draw a little bit more of this. This is a parabola. It's going to look like a cup. Okay, so another thing we can do to find another point is if we let x equal 0, okay, we let x equal 0, we're going to find our y-intercept. Okay, so I'm going to put that over here. Okay, if x is 0, this is 0 squared plus 6x, which is 6 times 0. Okay, sorry, plus 8. Okay, so that makes that 0, that makes that 0. So basically you're wiping out these two terms, these variable terms. So when x is 0, the y value is 8. Okay, so basically the y-intercept is this number right here at the end. Okay, if there's nothing here, then the y-intercept is 0. Okay, so when x is 0, y is 8. Okay, so 0, 8. So we're on the y. So this is going to be 1, 2, 3, 4, 5, 6, 7, 8. Okay, I'm going to extend this a little bit. Okay, it's right there. Okay, so what we know so far is this parabola is going up this way. I'm running into that. And then it goes up this way. Okay, and then later on, we're going to study how to find the vertex. But we kind of just imagine we can kind of draw this in right here. And that goes here and there. And then there's my parabola. Okay, so this is a parabola. Okay. And normally, if A is greater than 0, the parabola is going to open up. So if A is greater than 0, which is this number right here, then it's going to open up. So the coefficient of x squared is 1. So 1 is greater than 0. So it's going to open up. Now if this is negative, then it's going to open down this way. Okay, so we could actually kind of estimate or find this other point right here. So it's going to go right across from right here. And since this is they're mirror images of each other. Okay, I can put a line down there, an imaginary line. It's called the line of symmetry. And so if I just estimate, well, I can count here. This is 1, 2, and then the middle is 3. So that's the middle right there. So if I count 3 this way, it's going to be 1, 2, 3. So if this is 3 this way, and then up here, that's this point right here. Okay, so if this is 3, this is 4, 5, and 6 is here. Okay, so this is actually -6. -6, 8 is my other point right here. That's this point right here, -6, 8. And you could check it if you want. -6 squared is 36. -6 times -6 is positive 36. And then 6 times -6 is -36. So then that cancels out, and that gives us our 8. Okay, so basically, I wanted to show you the usefulness of factoring to find the x-intercepts here. If they cross, sometimes they don't cross, but most of the time they do. Okay, so there's that problem. Now the vertex, that's another lecture. The vertex, okay, we use this formula, x is equal to -b over 2a, and that'll give us the x value. And then to find the y value, we just basically plug this in back into the original equation here to get the y value. And then this should be, let's see, -1, -2. This should be -3 something here. So if I plug in a -3 here, that should give me my other value. But we usually use this formula right here. Okay, so again, the usefulness of factoring. We're factoring here. And one of the usefulness of it is to find the x-intercepts. The x-intercepts are where it intercepts the x-axis. Now, again, the y-intercept is where it's going to hit the y line here. And that's basically this number right here. All right. Okay, so that's that one. Okay, now real quick, I want to do this problem. This is a rational expression where we're going to use factoring again. Okay, so we're going to divide this. We're going to divide this. X minus 1 over 2x squared minus 2 divided by this. So just like regular factoring, we're going to multiply by the reciprocal of the divisor, which is this one right here. Okay, so this one stays the same. We don't do anything with this first fraction. Okay, but so what I want to do is I want to factor this real quick. Okay, I want to factor out a 2. That's the GCF. That's x squared minus 1. Okay, we have the difference of squares here. Okay, so on this one, this is still factored further. So this can be factored to 2 times x plus 1, x minus 1. Okay, I didn't anticipate that second move, but we factor out the GCF, then factor it again. Okay, so this is completely factored. Okay, now we're going to multiply this by the reciprocal of this, which means the reciprocal, we're going to switch the numerator for the denominator. We're going to switch these two terms here. Okay, so the 6 goes up here on the top. So instead of writing 6, I'm going to write 2 times 3 because I switched it up there on the top. And then on the bottom is 3x plus 3, and I need to factor out the GCF from here. So the GCF from here, they have a 3 in common, so it's going to be 3 times x plus 1. Okay. All right. Now that I have everything factored, I want to start crossing out stuff that's the same. Okay, because remember, when they're the same, like a over a, anything divided by self is 1. Okay, so basically what we do is we can cross these out, and that's going to equal 1. 1 over 1 is 1. But remember, a cannot equal 0 because you can't divide by 0. Okay, so let's look at this carefully. What can we cancel before we multiply across? Okay, they have this in common, x minus 1. So we're going to cross this out, and I'm going to put a 1 here and a 1 here. Okay, what else do we have? Okay, we can cancel up and down this way. So we can cancel these 3's. Okay, 3 over 3 is 1. Put a 1 there. Oh, and then there's a 2 right here. This 2 with this 2. So that gets canceled. See, the canceling part is fun. It's the factoring that people don't like. But if you know how to factor, this could be a fun problem. Once you get it all factored, it's easy to just look at them and seeing which ones are the same. Not too bad. Okay, so now what do we have left on the top? It looks like everything got canceled on the top. Okay, so we have 1 times 1 here times 1. So 1 times 1 times 1 is 1. So this is 1 over. And then on the bottom, we didn't cancel this x plus 1. So we have 2x plus 1s. Oh, I need to put this little 1's going to escape. Need to put a little fence for him, a little parentheses. Okay. Get the little parentheses there. Okay, so x plus 1. We have 2 of them. So then what do we write? We write x plus 1 squared. Okay, and this should be my final answer. Okay, again, I'm trying to show you the usefulness of factoring. And this is just a review of fractions. You multiply by the reciprocal. Here we factored out a 3. We got 3 times x plus 1. This was 2 times 3. And then over here we factored out a 2. But then what we had left over was the x squared minus 1. And that's a special factor. Special product, I should say, or special factoring. And so this is x plus 1, x minus 1 with a 2 there on the outside. Okay, so then what we had left was these 2 right here, and we're multiplying across. So we have x plus 1 squared. So let me put a little box around there, and that shows our answer. Okay, so again, we're studying factoring, and this is showing the usefulness of factoring. All right, I hope this helps. You get motivated to study factoring, because this will make, if you take more advanced classes, they'll make those classes go a lot smoother. If you know how to factor all the different types of polynomials. All right. And see you guys next time. Bye-bye.